Hello. Hello and welcome to this video. In this video, we will resume the study of XML related functions. So it will take probably two more videos to finish the documentation and then we will see an example. So we will continue at 9.15.2 XML predicates. The expressions described in this section check properties of XML values. The first predicate is document. So you supply a piece of XML and then you invoke is document, which will return a boolean true or false. The expression is document returns true if the argument XML value is a proper XML document. False if it is not, that is, it is a content fragment, or null if the argument is null. Section 8.13 talks about the difference between documents and content fragments. Then we have is not document. The expression is not document returns false if the argument XML is a proper XML document. True if it is not, that is, it is a content fragment, or null if the argument is null. Then we have XML exists, and the text is passing by ref or value, XML by ref or value, and then null. The function XML exists evaluates an XPath one expression, the first argument with the past XML value as its context item. The function returns false if the result of that evaluation yields an empty node set, true if it yields any other value. The function returns null if any argument is null. A non-null value passed as the context item must be an XML document, not a content fragment or any non-XML value. So here we are looking for a town which has content text Toronto. So if you look at the first town, that itself is Toronto, or however you pronounce it. So that's why it returns true. The by ref and by value clauses are accepted in PostgreSQL but are ignored as discussed in section D.3.2. In the SQL standard, the XML exists function evaluates an expression in the XML query language, but Postgres allows only an XPath1 expression as discussed in section D.3.1. Then we have XML is well-formed predicate. So it has three variations. One is XML is well-formed, then well-formed document, then well-formed content. All take text argument and return boolean. These functions check whether a text string represents well-formed XML. Returning a Boolean result, XML is well-formed document checks for a well-formed document, while XML well-formed content checks for a well-formed content. XML is well-formed does the former if the XML option configuration parameter is set to document, or the latter if it is set to content. This means that XML is well-formed is useful for saying whether a simple cast to type XML will succeed, whereas the other two functions are useful for saying whether the corresponding variants of XML parse will succeed. So the first one is we are checking XML is well formed, and we have set XML option to document, and we provide an empty tag which is not closed, so it is not well formed. Then we have well formed ABC self-closing tag is there, so it is true. Then we have ABC, so it is set to content, so it is true. And then well-formed document is there. So pg-foo, XML namespace pg, HTTP URL is there, and that is an attribute. And then we have bar, so it is well-formed document. And then we have another one for well-formed document where it looks at the section my column. So you see this closing tag doesn't match the opening tag, so it is false. Then we have the section related to processing XML. To process values of data type XML, PostgreSQL offers the functions XPath and XPath exist, which evaluate XPath1 expressions, and the XML table function. Covering XPath is really out of scope of this video series. You should learn it probably from some other online internet website or some other YouTube video. So XPath takes XPath text and XML and NS array as text namespace array and returns an XML array. The function XPath evaluates the XPath1 expression XPath given as text against the XML value XML. It returns an array of XML values corresponding to the node set produced by the XPath expression. If the XPath expression returns a scalar value rather than a node set, a single element array is returned. The second argument must be a well-formed XML document. In particular, it must have a single root node element. Two optional third argument of the function is an array of namespace mappings. This array should be a two-dimensional text array with the length of the second axis being equal to 2. That is, it should be an array of arrays, each of which consists of exactly two elements. The first element of each array entry is the namespace name, and the second is the namespace URI. It is not required that aliases provided in this array be the same as those being used in the XML document itself. In other words, both in the XML document and in the XPath function context, aliases are local. So first we have the XPath/my:\a/text. And then we have the text my:\a opening tag, and then we have a namespace, XML namespace, with the URL set to example.com, and the content is test. And this is again the closing element. Now we have a two-dimensional array. One is sets the namespace my, and the other sets the namespace URI, which matches the data in XML. And now we are looking at the text content of my:\a tag, which is test. So the value returned by this particular query will be test. To deal with default or anonymous namespaces, do something like this. So my definitions :b, we are looking at this particular tag text. So we have tag A with namespace set to example.com. That is the root tag, which contains tag B and tests B. Now the namespace is defined to be my definitions. The namespace is set to example.com to match this, and the XPath will return test. Then we have XPath exists. XPath_exist takes XPath, XML, and NS array and returns a boolean. So it is quite similar to XPath function we just discussed. The function XPath_exist is a specialized form of the XPath function. Instead of returning the individual XML value that satisfies the XPath1 expression, this function returns a boolean indicating whether the query was satisfied or not, specifically whether it produced any value other than an empty node set. This function is equivalent to the XML exist predicate, except that it also offers support for namespace mapping argument. Then we have XML table. So it takes XML namespaces and not optionally, namespace URIs, and followed by row expression passing by ref or value, document expression again by ref or value, columns name, and then type, and path is column expression, default expression is there, not null or null. So the things inside square brackets are optional, okay, while others are mandatory, and it returns set of record. The XML table expression produces a table based on an XML value, an XPath filter to extract rows, and a set of column definitions. Although it is syntactically resembles a function, it can only appear as a table in a queries from clause. The optional XML namespaces clause gives a comma-separated list of namespace definitions where each namespace URI is a text expression and each namespace name is a simple identifier. It specifies the XML namespaces used in the document and their clauses. A default namespace specification is not currently supported. The required row expression argument in an XPath1 expression given as text, that is evaluated, passing the XML value document expression as its context item to obtain a set of XML nodes. These nodes are what XML table transforms into output rows. No rows will be produced if the document expression is null, nor if the row expression produces an empty node set or any value other than a node set. Document underscore expression provides the context item for the row expression. It must be a well-formed XML document. Fragments or forests are not accepted. The by ref and by value clauses are accepted but ignored as discussed in section D.3.2. In the SQL standard, the XML table function evaluates expression in the XML query language, but PostgreSQL allows, we have seen this, the required columns clause specify the columns that will be produced in the output table. See the syntax summary above for the format. A name is required for each column as is the data type unless for ordinality is specified, in which case type integer is implicit. The path default and nullability clauses are optional. A column marked for ordinality will be populated with row numbers starting with 1 in the order of nodes retrieved from the row expressions result node set. At most, one column may be marked for ordinality. We have a note, XPath1 does not specify an order for nodes in a node set. So code that relies on a particular order of events will be implementation dependent. Again, details will be in the section D3.1.2. The column expression for a column is an XPath, one expression that is evaluated for each row, with the current node from the row expression result as its context item. To find the value of the column, if no column expression is given, then the column name is viewed as an implicit path. If a column's XPath expression returns a non-XML value which is limited to string, boolean, or double in XPath1, and the column has a PostgreSQL type other than XML. The columns will be set as if by assigning the value string representation to the PostgreSQL type. If the value is a boolean, its string representation is taken to be 1 or 0. If the output column's type category is numeric, otherwise true or false. If a column's XPath expression returns a non-empty set of XML nodes, and the column's PostgreSQL type is XML, the column will be assigned the expression result exactly if it is of document or content form. We have footnote 3 related to that, we will see. So this you might not see in the video because the font might be small for you. A result containing more than one element node at the top level or non-white space text outside of an element is an example of content form. An XPath result can be of neither form. For example, if it returns an attribute node selected from the element that contains it, such a result will be put into content form with each such disallowed node replaced by its string value, as defined for the XPath1 string function. We resume. A non-XML result assigned to an XML output column produces content, a single text node with the string value of the result. An XML result assigned to a column or any other type may not have more than one node, or an error is read. If there is exactly one node, the column will be set as if by assigning the node's string value to the PostgreSQL type. The string value of an XML element is the concatenation in document order of all text nodes contained in that element and its descendants. The string value of an element with no descendants text nodes is an empty string, not null. Any XSI nil attributes are ignored. Note that the white space only text node between the two non-text elements is preserved, and the leading white space on a text node is not flattened. The XML1 string function may be consulted for the rules defining the string value of the other XML node types and non-XML values. The conversion rules presented here are not exactly those of the SQL standard as discussed in section D.3.1.3. If the path expression returns an empty node set, typically when it does not match for a given row, the column will be set to null unless a default expression is specified. Then the value resulting from evaluating that expression is used. A default expression, rather than having evaluated immediately when XML table is called, is evaluated each time a default is needed for the column. If the expression qualifies as stable or immutable, the repeat evaluation may be skipped. This means that you can usefully use volatile functions like nextval in default expression. Columns may be marked not null if the column expression for a not null column does not match anything and there is no default, or the default expression also evaluates to null and error is reported. So here we have an example. So we create a table XML data as this is the example XML, which is created using data. So we have rows, row ID, country name. We have several countries. One is Australia, another is Japan. Then we optionally have premier name Shinzo Abe, and size is probably the size of the country, square miles. This is 145,935 square excuse me, miles. For Singapore, it is 697, but it is square kilometers. And then we are selecting rows and row. So all these tags will be selected. Returning data columns as path at the data ID. Okay, we are looking at ID. So 1 to 156 will be selected. Ordinality for ordinality. Country name is selected. It is expected. Okay, so country name is there for all of this. Country ID text pass country ID. So country ID will be also selected. Size square kilometer and size other, that is square mile, will also be selected because it is given. Unit is not equal to square kilometer, and then premier name is also selected. Default is not specified. Okay. So you see how this comes into picture. So first we have Australia. ID is 1. Ordinality is 1. Australia is the country name. Country ID is AU. Size per kilometer, size other, and premier name are not there. Premier name is not specified, which is the default. And then we have ID 5. Ordinality 2. Japan is there. JP. Area and square kilometer. Square miles is empty for this. It is square miles. Square kilometer is empty. And we have the premier name as Shinzo Abe. Then we have the Singapore. This time the size is in square kilometer, and remember the premier name is not specified. The following example shows concatenation of multiple text nodes, usage of column names as XPath filter, and the treatment of whitespace XML comments and processing instructions. So we have this XML piece of data. We have root element containing element. Element has text hello. And then we have a comment XY XXZ followed by more text 2A2. And then we have a shorthand which contains 5 A's followed by another comment followed by BBB and followed by XXX, a tag XXX. And then we have CC for element. Okay. So this is what is the content of that. Okay. Now we select only the root element here in the XML XPath expression, passing data columns element text. So if you see this, what namespace clause can be used to specify a list of namespaces here. Now we don't need to go there yet. Hang on. So we select the root. Now when we select this root, hello and 2A2 are concatenated. Okay. And then this is ignored. Okay. And we have BBB followed by XXX followed by CCC. Those were the texts of the root element. The following example illustrates how the XML namespaces clauses can be used to specify a list of namespaces used in XML documents as well as XPath expressions. So we have XML data. We take the data as values. Example namespace points to my namespace in example.com. And another namespace B is there pointing at example.com/B. Now we have several items, 3 to be exact, 1, 3, and 4 with the attribute foo, and 2, 4, 5 with the attribute name b:\bar. Now we select this and we specify the namespaces as X and B, and we select example, and that is the root tag here, and X:\item. So X:\item means we are looking at my namespace. Okay, and my namespace here is XML namespace. Okay, and example.com is B here. So let me look. Yeah. So we are looking for example item, and then further we are looking for attributes b colon bar and attribute foo here. Okay, and this bar should be an integer as well as foo should be integer. That's what we are looking at. And then we see that foo and bars are selected here. So I will stop here. It has been quite long reading. I actually get tired of reading all this documentation if it goes too long. So we will meet again in the next video, and we will resume here mapping tables to XML, and we will possibly finish the XML discussion. And after that, we will see an example. I'll prepare an example for you containing all this discussion which we have for XML functions and operators. So I hope that you are enjoying this video and finding my explanations useful and practical for your user of PostgreSQL. So thanks a lot for watching the video, and I'll see you in the next one. Stay curious and enjoy.